Hey guys, this is Arduino class number 2, and we're going to be talking about the joystick here at HSC. So, in the Arduino starter kit, this is called the joystick module. And this type of joystick is very similar to the analog joysticks on such as PlayStation 2 controllers. It's a self-centering spring loaded on a joystick, meaning that when you release the joystick, it will center itself. Now, the goal of the joystick is to communicate motion in 2D using two axes to an Arduino. This is achieved by housing two independent 10K potentiometers, one per each axis. These potentiometers are used as dual adjustable voltage dividers, providing two-axis analog input in the control stick form. Now, the potentiometers here are the two black housings on each side of the joystick. One is an x-axis potentiometer and the other is the y-axis potentiometer. And each of these potentiometers is picking up a movement in only one direction. We'll discuss how this works a little later on. This joystick also contains a push button, which activates if you push down on the cap of the joystick. The switch is a small black box in the rear of the joystick, and if you push down on the cap, you could see the lever pushing down on the head of the switch. Now, this works in whatever position the joystick is in, and if you look carefully, it's actually the same push button as the ones we have in our kit. The basic idea of a joystick is to translate the stick's position in two axes, as I stated, the x-axis and the y-axis into electronic information that the Arduino can process. This can be a little tricky, but thanks to the design of joystick consisting of two potentiometers and a gimbal mechanism, we could do this successfully. Now, when you rotate the joystick, the thumb handle moves on a narrow rod that sits on two rotatable soldered shafts called the gimbal. One of these shafts allow for the x-axis rotation, which is left and right, and the other allows for the y-axis, up and down. Tilting the stick forward and backwards pivots the y-axis shaft from side to side, and tilting it left to right pivots it on the x-axis shaft. When you move the stick diagonally, it pivots both shafts. In order to read the joystick's physical position, we need to measure the change in resistance of the potentiometer. Now, this is done by reading the Arduino analog pin using ADC. There is an electrical signal coming in, and because this is a resistive track depending on which area it connects to, there's a change going through the track from the wiper. Now, here's a diagram of our joysticks. It gives an output from 1023 to 0, and depending on the position it is, it could be 512 or any other number. Now we're looking at the pin layout. We're going to be starting from the left at ground, and this connects to ground in the Arduino. Next one is the 5 volt, and this is also called the VCC, and it supplies the power for the module. Next one is VRX, which is the readings for the x-axis, and it's how far left and right the joystick has been pushed. VRY does the same, but for the y-axis this time. Now, last is SW, which is the output from the push button. It's normally open, which means the digital readout from the SW pin will be high, but when the button is pushed, it will connect to ground and give the output of low. Now we're going to take a look at the wiring. This is the wiring layout that I'm going to be using. Please pause the video if you want to finish this and follow along. Alright, so now we're moving on to our coding. The sketch starts by initializing the connections of the joystick module onto the Arduino. The SW pin is connected to Arduino pin number 8, so it will be constant. And next is we're going to have to define the VRX and VRY pins, which are each connected to analog pin number 0 and analog pin number 1. Now that we defined these, we can move on to void setup. Now here we need to initialize the SW pin as an input and keep it at high. This is because as long as the SW pin is high, we know that the button is not pressed. So that will be pin mode, SW pin. Now this is telling it that the pin is an input. And now what we're doing is setting the SW pin at high. And the last thing we have to do is start the serial communication. Alright, now we've done this, we move on to our loop. In the loop function, we merely read the value of the SW pin using digital read, and the VRX and VRY pin using analog read, and display it on a serial monitor. Now this will be inputting the value we got from the SW pin in here. Now I'm going to be making a line. And now we're going to repeat this step for our analog read with the analog read function for our X and Y pins. And repeat it one more time for our Y-axis. And then we're going to have to put a delay in so we could see what it's printing out before it moves on. And now here we have to use print line so it could skip down a step. And now we verify and upload onto our Arduino. And we have to go to our serial monitor, and from here we could check what values come out. If we toggle the switch, we could see that there's different values coming out. And I hope you enjoyed this little tutorial. Thank you.